A functioning cog in some great machinery, serving something beyond me. But I don't know what that will be. I'll get back to you someday soon. You will see.
Alright, it's the last section in chapter 2. That's the good news. The bad news is the word applications. By this point in your life, you've probably learned to absolutely despise the word applications. Why is that? Because when you see applications, you know we're talking about word problems. Alright, stop groaning. We can do this. Okay, so we're going to use polynomials. We're going to try factoring polynomials. They're going to have cubics in there. I'm going to use the stuff we learned so far in this chapter, but we're going to answer word problems. Let's do 3 of them. First one, the height of a rectangular prism is 2 centimeters less than the width. The length is 4 centimeters more than the width. If the volume of the prism is 8 times the measure of the length, what are the dimensions of the prism? Okay, so let's start up here. The height of the rectangular prism, so a rectangular prism looks like a box, right? Something like that. The height is 2 centimeters less than the width. So we don't know the length of the width. What do you want to call it? Well, probably a lot of you are saying W for width, but I like using X's and Y's. So let's call the width, width equals X. Wow, again, I can't write. The height is 2 centimeters less. So the height then, what's 2 centimeters less than X? X minus 2. And the length is 4 centimeters more than the width. Not 4 centimeters more than the height, it's 4 centimeters more than the width. That's a little bit easier. So the length is 4 more than X. It's X plus 4. Okay, the volume, so we're talking about volume. How do you get volume? Volume is length times width times height. Oh, so we got to multiply these 3 things together. X times X minus 2 times X plus 4. And the total volume is 8 times the measure of the length. What's the length? The length is X plus 4, so our volume is 8 times X plus 4. Alright, here we go. Now we're ready to start multiplying. First of all, let's do mountains here, and we'll do mountains over here. You can do this in all sorts of different orders, but this is the order I'll do it. X times X is X squared. X times negative 2 is negative 2X. This is all going to be multiplied by this. And on the right hand side we have 8 times X is 8X, 8 times 4 is 32. Okay, now we're going to have to do some mountains and valleys. So we get X cubed, that's X squared times X. X squared times 4 is 4X squared. Negative 2X times X is negative 2X squared. Negative 2X times 4 is negative 8X. And we still have 8X plus 32. Let's get everything to one side, and let's keep our leading coefficient, in this case the X cubed, let's keep that coefficient positive. So we don't want to move everything to the right, we want to move to the left. So we have X cubed, let's combine these two, so we have plus, combine the X squareds, we have plus 2X squared. Bring this 8X over, becomes negative 8X, we have negative 8X, take away another 8X, we have negative 16X, and bring the 32 over, we have minus 32 equals 0. Okay, here's now we have to factor this, right? And it's a cubic, so this is the one we have to guess the factors. But remember, we can make things a little easier for ourselves. If we're looking for possible roots or possible zeros, we can take the factors of the constant and divide them by the factors of the leading coefficient. And look at the leading coefficient's 1. That's great. So that really has no impact. All we have to do is find the factors of 32. Factors of 32 are 1, 2, 4, 8, 16, 32. Plus or minus, right? But wait a minute. Could it really be plus or minus? Let's think about this for a second. We're talking about width and length and height. We're talking about distances. Can distances be negative? No. So in this case, we only have to worry about the positive ones. Nice. So we're left with 6 possibilities. Doesn't mean they all work, but it has to come from these numbers right here. All right, let's try 1. So if we put 1 in here, we get 1 cubed. That's 1. 1 squared times 2 is 2. 16 times 1 is 16, minus 32. Does that equal 0? No, it does not equal 0. So this one is gone. Okay, let's try 2. 2 cubed is 8. 2 squared is 4 times 2 is 8 again. 16 times 2 is 32. Take away another 32. Does that equal 0? Nope. This one's gone too. Hopefully it'll be soon. We don't want to do this all day. Just try 4. 4 cubed is 64. 4 squared is 16 plus 2 is 32. 16 times 4 is 64. And minus 32. Hey, that works. Awesome. So 4 is definitely one of them that works. What should we do now? Let's divide this by the factor. Now this is the 0. If the 0 is 4, what's the factor? The factor is x minus 4. So that's one of the factors. So we're going to divide this polynomial by that factor. How do you want to do it? Could do long division, or we could use synthetic division. I think it'll be faster. 1, 2, negative 16, negative 32. What number do you know absolutely positively is going to be right there? 0, right? Because we already know that 4 works. So we better get 0 there. Let's try it. Drag down the 1. 4 times 1 is 4. 2 plus 4 is 6. 4 times 6 is 24. Negative 16 plus 24 is 8. 4 times 8 is 32. Add those, you get 0. Perfect. What are we left with here? We're left with x squared plus 6x plus 8. Hey, we can factor that. That equals x plus 4, x plus 2. Remember, we already found one of the factors. It was x minus 4. And so basically what we've done is we've taken this statement right here and we factored the left hand side. So now we have that all this is equal to 0. Okay, if this is all equal to 0, one of these brackets or two of these brackets or three of these brackets must equal 0. What would make the first one equal 0? Negative 4. What would make the second one equal 0? Negative 2. What would make the third one equal 0? 4. So those are our possible answers. But again, we're talking about real life stuff here, remember? We're talking about widths, lengths, heights, distances. What answers don't make sense? This makes no sense. You can't have a negative distance. You can't have a negative distance. Hey, x equals 4. So in other words, the width is 4, the height is 4 minus 2 is 2, the length is 4 plus 4 is 8. So the dimensions are 4 times 2 times 8. There's your answer. Okay, quite a bit of work, isn't it? Next one, 3 consecutive odd integers have a product of negative 105. What are the integers? Okay, so we got our first number, our second number, our third number. Guess what we're going to call the first number? X. Now be careful, they're 3 consecutive odd integers. That's like 5, 7, 9, 15, 17, 19, right? Those are consecutive odds. So if we have one odd number, how do we get to the next odd number? A lot of people think it's x plus 1 because it says odd, but that's not true. To get from one odd number to the next odd number, you have to add 2. What do you do to get from 15 to 17? Add 2. What do you do to get from 21 to 23? Add 2. So you always have to add 2. How much do you have to add to get to the next one? You got to add 4. Okay, the product, that means multiply. So we're going to multiply those things together. And we're going to get an answer of negative 105. Okay, here we go. Do that first. So we get x squared plus 2x. We're going to multiply all of that by x plus 4. Mountains and valleys time. X squared times x is x cubed. X squared times 4 is 4x squared. 2x times x is 2x squared. 2x times 4 is 8x. Bring the 105 over, so we get plus 105 equals 0. I think you can combine some stuff. Yeah, the x squareds, 6x squared plus 8x plus 105 equals 0. Okay, possible zeros or possible roots. Leading coefficient's 1 again. We love that, so you just have to worry about the factors of 105. 1, 3, 5, 7, 1, 3, 5, 7, 15, 21, 35, 105. Those are all the factors. Okay, now let's look at this. All of these are plus, like positive, plus, plus, plus. So you know how we usually put plus or minus in here? Do you see that in this case they actually, the pluses will definitely not work. The positive numbers will definitely not work. How come? How do you know the number has to be negative? Because if you have a positive, and then you've added another positive, and then more positive, and then more positive, there's no way you can ever get to 0. You must have some negatives in there to make it come back down to 0. So let's start with the smallest number, negative 1, and hope we get to it really quickly. So here we go, negative 1. Negative 1 cubed is negative 1 plus Negative 1 squared is 1 times 6 is 6. Negative 1 times 8, negative 8, plus 105. Does that look like it equals 0? No way. So negative 1 doesn't work. Let's try negative 3. Negative 3 cubed is negative 27. Negative 3 squared is 9 times 6 is 54. 8 times negative 3 is negative 24. And then add 105. Does that look good? No, that doesn't look like that's going to work either. Alright, please work soon. Negative 5. Negative 5 cubed is negative 125. Negative 5 squared is 25 times 6 is 150. This is looking better. Negative 5 times 8 is negative 40 plus 105. We got 165 negative and 255. No, we're not there yet. This is annoying, is it not? Please, negative 7. Uh-oh, I don't even know what these things equal. You know what? Let's do this. Let's hope and pray that negative 7 works. And let's go straight to, and you could also do this, instead of doing what I've done in red here, you could just keep doing synthetic division, because synthetic division is actually pretty fast. So you could do this. How will I know if I use synthetic division whether it works or not? Because I'll be looking for 0 right here, right? I think this does work. Let's hope. Bring the 1 down. Negative 7 times 1 is negative 7. 6 plus negative 7 is negative 1. Sorry. Negative 7 times negative 1 is 7. 8 plus 7 is 15. Yes! Negative 7 times 15 is negative 1 of 4. Negative 1 of 5, sorry. We did it! So we got it. One of our roots is negative 7, which means our factor is x plus 7. What are we left with? X squared minus x plus 15. Can we factor that? Looking for two numbers that multiply to 15 and subtract to x and add to 1. Sorry. Multiply to 15, add to 1. No such numbers. We'd have to use the Pythagorean. God, what's going on with me today? You'd have to use a quadratic formula. So before we use quadratic formula, though, let's just check by using the discriminant. Let's just check what this equals. B squared, that's negative 1 squared, which is 1, minus 4, a is 1, c is 15. You end up with something like negative 59. It's less than 0. Remember what that means? No solutions. So the only solution you actually get is no real solution. So the only real solution you get is x plus 7 is the only factor, which means the only actual x we have is negative 7. Our answer is negative 7. So if x is negative 7, that means our numbers are negative 7 plus 2 is negative 5 plus 2 is negative 3. The numbers are negative 7, negative 5, negative 3. Oh boy, that was a lot of work too. Last one, these ones are very common. I think they're very popular in your book, so make sure you watch this one. Don't give up yet. An open rectangular box. So we have a box, I don't know, like that. It's constructed by cutting a square from each corner. So you cut a square out there. You cut the same size square there, same size square there, same size square there. Do you see that if you folded along this, so you cut these corners out, and if you fold it up, fold it up, fold it up, whoops, fold it up, you'd be left with a box. It would have no top to it. It would be an open box. Okay, that's the idea here. So originally, the size of this thing was 8 centimeters by 10 centimeters. And then you're cutting a little square out, and the question is, how big should the square be? In other words, we don't know the length of the square, so why don't we call it x? This is x, this is x, this is x, this is x. All these little square sides are x. Now, when we fold up the box, the base of the box will be this green rectangle here. How big is that side of the green rectangle? It's not 10. 10 was the whole way from here to here. So what have we taken away from the 10 to get this green one? We've taken away an x here and an x there. In other words, we have 10 take away 2x. How about this dimension here, this green distance here? It's not 8, that's what the whole thing was, but once we take away the x here and the x here, we're left with 8 minus 2x. So to get volume, you go length times width times height. What's the height of the box once you fold it up? Once you fold it up, you know me, I can't draw, but once you fold it up, do you see that one of these x's like that right there, that'll be the height. The height is now x. And we want to know when is the volume equal to 48. So length times width times height equals 48. And here we go again. You can see they're all kind of similar once you get the actual question. 10x minus 2x squared. We're going to multiply that by 8 minus 2x. Mountains and valleys. 10x times 8 is 80x. 10x times negative 2x is negative 20x squared. Negative 2x squared times 8 is negative 16x squared. Negative 2x squared times negative 2x is plus 4x cubed. Bring the 48 over, equals 0. Let's rewrite this in the correct order, descending orders. So 4x cubed comes first, then comes our x squared. So we actually have negative 36 if we combine them. Then our 80x, and then take away 48 equals 0. Okay, before we try factoring this, well, what's the first step in factoring we could do here? We could divide them all by 4. And then we can just get rid of the 4 because it's equal to 0. Remember, you can always do that if it's equal to 0. So divide them all by 4, we get x cubed minus 9x squared plus 20x minus 12 equals 0. Okay, possible roots are, again, we've ended up with a leading coefficient of 1. That's wonderful. So we just have to look at the factors of 12. 1, 2, 3, 4, 6, 12. Okay, now we can eliminate plus and minus, right? But again, think of the question. We're talking about a distance. You don't need the negatives, so we can already get rid of those. You can even get rid of more of these. If this distance here is 8, could you possibly cut out 12 and 12? No, it's too big. Could you cut out 6 and 6? No, that's still more than 8. Could you even cut out 4 and 4? Not really. That means you'd cut it right in the middle. That's no box. So you're left with only 3 possibilities. This is great. This isn't going to take long at all. Let's try 1. 1 cubed is 1. 1 squared times 9 plus 20 minus 12. That's 20. Yay, it worked. First try. Awesome. So we've got 1, which works. And then we have 1, negative 9, 20, negative 12. Bring down the 1. 1 times 1 is 1. Negative 8, 12, 12, and 0. It worked because we got the 0. What are we left with? X squared minus 8x plus 12. Can we factor that? Yes, we can. Two numbers that multiply 12 and add to 8, 6 and 2. So x minus 6, x minus 2. And we already found one of them. We found that the root that worked was 1, which means our factor is x minus 1 equals 0. So what are our answers then? 6, 2, and 1. Okay, should we get rid of any of these? Well, none of them are negative, so that's good. But look, we already said up here you couldn't have 6. It's too big. You can't take 6 and another 6 from 8. So this one is gone. So it ends up you have 2 possibilities. You could remove each of these squares could be a 1 by 1 square, or each of these squares could be a 2 by 2 square. I don't know. The square sides could be 1 centimeter or 2 centimeters. 2 possible answers in this case. Okay, that's it. Done. Some tough questions in the workbook. Good luck, and enjoy your word problems, people.
If I had an orchard, I'd work till I'm wrong. If I had an orchard, I'd work till I'm sore. And you would wait tables